Welcome back to The Explainer. Today, we're looking at a system so massive, so incredibly ancient, that it literally powers all life on our planet. We're talking about the water cycle, which is truly nature's endless journey. Let's get right into it. Okay, let's dive into this. Have you ever actually stopped to wonder how dense, super salty ocean water manages to travel thousands of feet straight up into the sky, only to come back down to Earth as completely fresh rain? Honestly, it's a brilliant mechanical process when you really think about the sheer scale of it. And figuring out exactly how nature solves this giant puzzle is what we're going to explore today. Think of this continuous water loop as the real hero of our story. It's a never-ending process, constantly shuttling water between our vast oceans, way up into the atmosphere, and eventually back down to the land. But to really understand this journey, we've got to go to the very beginning. We need to see exactly what acts as the catalyst for this massive global movement. And this brilliantly illustrates the immense scale of our starting point. A staggering 97% of all the water on Earth lives right here in our oceans. Every single day, the sun acts like an enormous planetary engine, radiating absolutely incredible amounts of energy straight down onto this gigantic liquid surface. All that solar energy triggers our very first phase, evaporation. As the sunlight warms the surface of the ocean, millions and millions of tiny water molecules absorb that energy. They start moving faster and faster, until, eventually, they break free. They literally escape the liquid surface and shoot up into the air as an invisible gas we call water vapor. Now, what's really interesting about this slide is the aha moment built right into nature's design. When that ocean water evaporates, only the pure water molecules make the leap. All those heavy salts and dissolved minerals, they are left completely behind. So the incredibly salty sea essentially transforms itself into perfectly fresh water vapor. It's nature's ultimate purification system. Let's move to and see how this builds. We're going to follow our freshly purified water vapor as it rises higher and higher into a much cooler part of the atmosphere. And that temperature drop triggers the next big physics trick, condensation. As that warm, moist air rises, it hits those cooler atmospheric temperatures. And since cold air just cannot physically hold as much vapor as warm air, that invisible gas is forced to transform right back into tiny liquid droplets. What happens next is a totally fascinating micro-narrative. You've got these billions of cooling liquid droplets, right? But they actually need a little foundation to cling to. So they gather around microscopic atmospheric debris floating up there. We're talking specks of dust, stray pollen, or even tiny bits of sea salt. They cling onto this debris, huddle together, and that is exactly how they form clouds. We definitely need to dispel a common illusion right here. Clouds might look like weightless, fluffy cotton candy just peacefully floating overhead, but no. They are massive, incredibly heavy water carriers. Pushed around by global winds, they act like a high-speed transit system, ferrying countless tons of fresh water all the way across oceans, over vast plains, and past towering mountain ranges. But you know what they say, what goes up must come down. The molecules are about to face the ultimate trial of gravity and make their return journey home. So the crucial point is that inside those clouds, water vapor is just continuously condensing. The droplets merge, they get heavier and heavier, and eventually, the sheer accumulated weight totally overcomes the air's physical ability to hold them up. Gravity takes over, pulling them relentlessly back down to the surface as precipitation. And as this water rushes back down toward Earth, it encounters wildly different atmospheric temperatures. Depending entirely on what it falls through, this precipitation takes on some distinct forms. It could be liquid rain if it's warm, intricate snowflakes and freezing temps, or even sleet and heavy hail if conditions get turbulent on the way down. But think about what happens the exact second it hits the ground. All this falling water rushes to replenish our rivers, our lakes, and streams, and crucially, a huge amount of it seeps deep underground to refill natural aquifers. Those are the exact same aquifers that supply clean drinking water to millions of us every single day, all before the remaining water finally winds its way right back to the ocean. Let's just take a step back for a second. I want us to look at the ultimate, all-inspiring impact of this endless loop on our planet. Billions. That is the massive number you really need to grasp here. This complex, magnificent climate system hasn't just been operating for a few centuries. It has been running continuously, day in and day out, for billions of years. It's literally the steady beating heart of Earth. And every single step relies entirely on the one that came before it. Without evaporation, those massive water carriers, the clouds, they'd never form. Without clouds, we'd have no fresh rainfall. And without that rainfall, every single living thing on Earth, plants, animals, us, would utterly struggle and eventually fail to survive. I want to share a rather profound thought with you. Every drop of rain that falls may have once been part of an ocean, a river, a glacier, or even a cloud thousands of miles away. It is such a spectacular reminder of how deeply, beautifully connected the natural world truly is. So I'll leave you with this. The next time you look out your window and see the rain coming down, what are you going to see? Will it just be water hitting the glass? Or will you see the remarkable billions-year-old journey of a single drop, powered by the sun, guided by the atmosphere, and absolutely essential for all life? Thanks for exploring this amazing system with me on The Explainer today. Never stop being curious.